Now, coming to the second idea, multicollinearity. Now, a multicollinearity is defined as an idea whereby our independent variables are itself highly correlated with respect to each other. Now, one very popular way to figure out multicollinearity, do I have it? Have that slide here? Yeah, detect. It's here. Okay. So maybe I'll talk about that in a bit. There's an easy way to do it visually also. But this is the definition of multicollinearity. We'll see more details further. So, although it's not exactly a violation of regression assumptions, the presence of multicollinearity will certainly have an impact on the reliability of the parameter estimation which we make as a part of the model. So that's why treatment of multicollinearity becomes very, very important. Now, if the x variables in our multiple regression setup are perfectly correlated with respect to each other, we call this scenario as perfect collinearity. So just a type of multicollinearity. Now, what are the effects of multicollinearity? So, one is whenever there exists a multicollinearity, there is a higher probability that we might end up incorrectly concluding that a certain variable is not statistically significant. So, something which you also call as a type 2 error in statistical analysis. So, that is something which can happen. And actually, we want to counter this problem. Another effect of multicollinearity is it might so happen that we might unnecessarily end up making the model more complex. That is, let's say if we have a set of independent parameters which we use, and let's say we don't bother about multicollinearity and we directly use parameters. Now it may so happen that two parameters, let's say y and z. Now let's say those two parameters are independent parameters in the model. Now, they may be highly correlated, and it may so happen that if we don't do this check further, we might just end up using both of them as a part of our modeling exercise. Now, again, this is something which becomes important from the idea of machine learning as well. So, remember that even in machine learning, we try to rely on the idea or we try to follow the idea of a parsimonious model. That is, we need to reduce the number of independent variables or independent parameters which go into the model so that it becomes easy for us to tune the model as well. Now, if we do not do a check for multicollinearity, but we still end up using multiple variables which go into our setup, the problem is we end up using a large number of independent variables, many of which would convey a similar information. So that way, having two variables which convey the same thing doesn't add any value to our overall modeling exercise. So that can be another effect. So this is something which we need to carefully handle, because if there is multiple correlation or what we call as multicollinearity, that is something which needs to be tackled so that we keep our model setup simple. We don't end up with a very large number of independent variables, which can be a problem. Now, a couple of popular ways in which multicollinearity can be detected. So one is discrepancy in hypothesis test results. Uh, So let's say that we have a condition or we have a situation whereby t-tests indicate that none of our independent variables individually are significantly different than zero. However, let's say the r squared, which is our coefficient of determination, is very, very high. And also, let's say the f test rejects the null hypothesis. So how exactly do we conclude or how exactly do we interpret this kind of a scenario? So this suggests that whenever we consider the variables together, so there should be an S here. So whenever we have all of the variables together as a group, they explain the variation in the dependent variable. However, individual independent variables are not able to explain it to that kind of an extent. So that happens whenever there is so much amount of high correlation between each of them. So another simplified way to look at this is whenever there is a high level or high degree of correlation between variables, it will tend to wash out the effects of individual variables on our overall result. So one is by looking at the results of hypothesis tests, we can figure out if there is a multicollinearity which may exist as well. Next is computation of what we call as a VIF factor, or variance inflation factor, or VIF for short. So we can calculate the VIF for each independent variable. So there's a standard process by which VIF scores can be calculated. Again, with good quality scripting tools like Python, it becomes even easy for us to compute these kind of things. So let's see how a VIF score can be calculated for one variable. Once we know it for one variable, extending that to n number of variables becomes very, very convenient. So we calculate the R square in the model using a subject explanatory variable. I'll choose to call it as xj. And we'll treat this variable xj as a dependent variable and all other remaining x variables as independent variables. So using a standard equation, we have this linear setup, right? So we have xj on the left hand side, which is our dependent variable, and we have other things on the right hand side. We figure out this r squared. Now, the r squared which comes in, we plug it into the standard VIF formula, which is given below. And how do we interpret the VIF result? So if VIF is greater than 10, generally R squared greater than 90%. Now it should be considered that this can be a bit problematic for that particular variable. So this can basically tell us that the problem of multicollinearity can bother us subsequently. So that way, once we do it for one variable, we can then make it for maybe xj plus 1. And we can use that as the dependent parameter and others as the independent and run similar setups. Again, with scripting tools, these kind of calculations can easily run in the form of a loop, and you can it is. And if I remember correctly, Python within the stats model library, you also have a VIF calculator which goes in. So that way you have a ready library to compute your VIF scores.